Okay, let's have a look now. A woman can swim at U in still water. In a river, she can cover a distance d against the current in time t1 and the same distance with the current in time t2. The current flows parallel to straight banks at v. Show that v. Okay, so maybe I could start with the total time. So time is distance over speed. So first she swims d against the current. So that'll be u minus v. And then she can swim. Well, actually, maybe I don't want to add them together just yet because of the result. I'll just separate them for the moment. And yeah, let's just see. Okay. D over u minus v, and then t2 is d over u plus v. Now I want to combine these equations. These equations do not have u. This equation does not have u in it. So I think what I can rearrange as u minus v equals d over t1, and then u plus v equals d over t2, and then if I subtract, i.e. equation 2 minus equation 1, u minus u is gone, v minus v is 2v equals d over t2 minus d over t1. So that means 2v equals t1 t2 dt1 minus dt2. So v equals d t1 minus t2 over 2 t1 t2, which is perfect. The width of the river is d. Interesting. And v is less than u. V has to be less than u. We kind of knew that at the start. So that's not really too interesting. Find in terms of T1 and T2 the time taken by the woman to cross the river by the shortest path. Okay, so I'm going to draw this out. We've got the river, and the width of the river is d. And it's still flowing at v. And remember, she can swim at u. And she wants to go by the shortest path. So that means she'll have to... I could do this using the vectors if I wanted to, but you can just think about it algebraically. Like, to cancel the effect of the downstream, she'll have to set v left here. Her diagonal is u here. So I can find this just from Pythagoras as the square root of u squared minus v squared. So that's what her velocity vector will look like when resolved. So if I resolve this, if I resolve this vector, I'll get this situation, v to the left and root u squared minus v squared across. These v's will cancel. So the crossing time would be d over root u squared minus v squared. But I don't want that. So I'm going to have to simplify it. What to sub in? I'm probably being hinted to replace the v because we just had to find the v previously. But that doesn't quite get rid of the d's. Also, this is u plus v, u minus v. I'm going to make a bold move. I'm going to square everything for a moment. That becomes d squared. That becomes u minus v, u plus v. That's equal to d over u minus v and d over u plus v, which we can identify as t1 and t2. So that's equal to t1, t2. So therefore t is root t1, t2. So I feel like that was a little bit misleading, because although I guess, okay, fair enough, my previous answer helped me, but it wasn't the result of my previous answer that helped me, but what I did at the start. Yeah. Okay. I think that's okay. Let's have a check.
Yeah, actually, I realise I have no way of checking, so I just assume and hope it's right, and let me know if there's a problem.